Good morning, students. Already we have completed the nomenclature and the structural formula of a different organic compounds. Today we will know about the alkanes. Okay, the alkanes, the general formula of alkanes is CnH2n plus 2. That means if you observe this formula, it is having one carbon and it is having more number of hydrogens, and it is balancing, or it is getting, the carbon is getting the tetravalency, so that the elements which are having, or in the alkanes, the carbon which is having in the alkanes is satisfied with the hydrogens itself by the single bond. As if it is satisfied with the single bond, these alkanes are called as saturated hydrocarbons. These are called as saturated hydrocarbons. And if you see this CnH2n plus 2, let us see that if n is equal to 1, then what is the alkane we are getting? This is C1H4. If n is equal to 2, then we are getting C2H6. And these are the different hydrocarbons of alkanes. These are the different alkanes. So the first one is the methane, and the second one is the ethane. And the next one is, that means according to the root words, already we have known the root words. If one carbon is there, it is called as meth, and the suffix as if it belongs to the alkane family, so that it is, we are using the suffix as ane, so that this is methane. And two carbons eth, and as if it is of the alkane family, it is ethane. And if three carbons are there where n is equal to 3, C3H8, and we call it as propane. Okay, so like that it is satisfied with the general formula CnH2n plus 2, and it is having all the single covalent bonds, and as if it is satisfied with the tetravalency, we will call it as a saturated hydrocarbons. These alkanes are called as saturated hydrocarbons, and they will be following of the same properties. That means these elements, if they are undergone for the combustion reaction. What is combustion? Burning of an substance in presence of the oxygen is called as the combustion. If methane is burned in presence of the oxygen, it will be giving out carbon dioxide as well as water vapor will be given out. Not only this methane, even the higher alkanes also, if they are burnt in presence of the oxygen, they also will be giving the carbon dioxide as well as water vapor itself. That means they will be exhibiting of the similar type of properties will be exhibited, and these will be undergoing similar type of reactions. These similar type of reactions are called as substitution reactions. These alkanes will be going the same type of reactions. Those are called as substitution reactions. And as if these are going the substitution reactions, that means actually already they are satisfied with the tetravalency. They are not ready to participate in the reactions, and they will be reacting very slowly. Okay, these will be reacting very slowly. That's why the other name for these alkanes is paraffins. Other name for these alkanes is paraffins. The meaning of paraffins means very little affinity towards the reactivity. That means they are very less reactive in nature. Why? Because already they are satisfied, they need not participate in the reactions. Okay, children. Then we will know about the homologous series. Already we have discussed about the homologous series in the earlier classes. What is homologous series? If any two of the compounds, any two of the elements are differ by the CH2 group, that is called as a homologous series. If you observe here methane, ethane or ethane, propane, there we can see a difference of CH2. If there arises a difference of CH2, this is called as the homologous series. That means these are differed by a homologous series. And we can have the different structures and molecular formulas. If the same element, same molecular formula is given and different structures are there, what do you call that phenomena? That phenomena is called as isomerism. Even in the alkanes, we can see that isomerism, but we can't see this isomerism in the either methane or ethane or propane, but we can see this isomerism from the fourth carbon element itself. That means from the butane itself we can see this isomerism. Let us see the homologous series of the alkanes. Here first we will draw the structure. Name, molecular formula, structural formula, and abbreviated formula. And abbreviated formula or abbreviated formula is also called as a condensed form. The name itself is methane. Okay, the molecular formula is CH4 and the structural formula is like this. And the abbreviated formula is C with 4 hydrogens. In the same way, ethane, C2H6. And the structural formula, C, 2 carbons are there, no? Write it according to the skeletal form. Then this is the structural formula, but don't get confused for both. This is the structural formula, and then this C with 3 hydrogens, again C with 3 hydrogens. This is the abbreviated or condensed formula. The next one is propane, is also same way. So let us go for butane. Butane, C4H10. Then we will draw the structure of butane. But means 4 carbons. So draw the 4 carbons as if it is like other alkanes, so that we call it as N-butane. We call it as N-butane. Normal butane. N stands for normal. So this is the structure of N-butane. So how we can write it in the abbreviated form? Here CH3, CH2, CH2 and CH3. We will write in the same form. CH3, CH2, CH2 and CH3. This is the normal butane. And so here also we will get the same molecular formula, but different name and different structural formula will be there. This is called as isobutane. Isobutane, and this isobutane is the common name, but for this the IUPAC name is 2-methyl propane. Now let us draw the structure of this isobutane or 2-methyl propane. So here root word is prop, that's why 1, 2, 3, and On the second carbon is the methyl group. So here we will be having the methyl group. Okay. So this is called as isobutane or 2-methyl propane. And here the abbreviated structure is CH3 CH3 and down the substrate will be there. So this is the abbreviated or condensed form of the isobutane. That means here for the butane we are having the isomers. As if the isomerism will be started from the fourth carbon from the alkanes, and as if butane is having butane is having 2 isomers and the number of isomers for pentane is 3. Okay children, and the sources of alkanes and how these alkanes will be available. The main sources of the alkanes is natural gas as well as petroleum. Natural gas and petroleum. And from the natural gas we will be getting the methane. From the natural gas more amount of petroleum will be available, and in very less quantity we will be getting the ethane, propane and butane. And from the petroleum products we can be getting the other alkane products, even from the LPG. That means we are using the LPG. What is the full form of LPG? The full form of LPG is liquefied petroleum gas. That it contains butane, which is used for cooking. Understand? And already we have discussed about the isomerism and as well as isomers. Okay children. So we will be discussing the remaining part in the next class. Thank you.